All right, welcome back, guys. So today what we're going to be looking at is a couple different things. The first thing we're going to be looking at is a thing called the zero product property, which I love to call it. I call it the ZPP. So anytime you hear me say ZPP, you should be thinking zero product property. All right, so what I'm going to do is I'm just going to put up something here where if you look at this, this kind of explains what factored form is. Now, up here you'll see standard form is what you guys are mostly used to. You're used to like x squared plus 2x. That is standard form, right? Where we talked about that, putting a polynomial in standard form. Now the factored form is when you basically break it up into factors. Think about what factors are. Factors are when you multiply terms together to get something else. So let's say if I said what's the factor of, say, like 25. You guys would say, well, I know 5 times 5 would be 25. So 5 and 5 are factors of 25. Or you could also do like 25 and 1 would also be factors. So think about what factors are. Factors are when you're multiplying together. So the products of a number, or for a particular one like the one that we have here where it says x squared plus 2x, the factors of that, or the products of that, would be x times the quantity x plus 2. So that's factored form. In the beginning of this video, we're basically just going to start with factored form, and then eventually we'll go from standard form to factored form. So I'm going to show you how to do that. Alright, so the first thing that we're going to look at is this example here. Alright, so in this example we have 2x times the quantity x minus 4. So this is in factored form because I have two factors. I have 2x is one of my terms, is one of my factors, I should say, and my other factor is x minus 4. So if that's the case, right, we can use the zero product property. Now I didn't really explain the zero product property too well previously, so I'm going to do that now. So what the zero product property means is if one of these terms is equal to 0, then this whole side would be equal to 0. So that's what I'm trying to do. The whole goal of this is to figure out how can I find the value for x that's going to make the whole equation equal to 0. Now, you have to think, well, how am I going to do that? Well, what you're going to use is you're going to use the zero product property. So all you have to do, and it's a very straightforward concept, is you set both of these equal to 0. Because if this piece right here, right, if that's equal to 0, then the whole thing would be equal to 0. So that's going to be one of my solutions. And then also here, if this is equal to 0, then the whole thing would be equal to 0. So you could just solve this and you know x would be equal to 0, or x would be equal to 4. So right there, that's your solution. Now, sometimes you might hear me call these roots. So these are also called the roots. So these solutions to these problems, you might hear me say roots, solutions. There's other terms for them too that I'll use later on. But for now, that's how you would do that. And we'll look at a different example. All right, so if you take a look at this one, here's a new example. I have two factors. This is in factored form. So if it's in factored form, that means that I can use ZPP. So all we have to do is go, okay, if this is equal to 0, the whole thing would be equal to 0 because that's what I'm trying to do. I'm trying to find the solution. I'm trying to find the root. The root is what makes this solution equal to 0. So all you have to do, and most of you guys can do this in your head, but I'm just showing you what we're really doing in our head. So then you actually put or here because there's two possible answers most of the time. There could be more than two, but for now, most of these will have two. So one root would be x equals 3, and the other one would x equals 9. So you're using the zero product property to solve these. That's all we're doing. We're setting each factor equal to 0. Once we do that, we solve it and we're done. All right, now let's look at an example like this. Now, remember before on the examples I was saying that the answers were called roots. Now, let's look at this, because I'm going to get back to the roots in a minute, but there's a thing called the repeated roots. Now, if I were to solve this, I would want to write it in factored form, right? Which you guys know how to do, or you should be able to see that that's factored form. So now, in factored form, you'll see that you rewrite it out, right? Or x minus 1 equals 0. You should see that those are both identical, right? So when you go to solve them, you get x equals 1 or x equals 1. What that is called, that's a repeated root. So that will happen. So this will have a repeated root. You don't have to list both of them. You can say just a repeated root of x equals 1. So you could write both of them, but you should say it's a repeated root so you know that it happens twice. Now when we get a little bit further along, remember this, because when we go to graph and things like that, this means something. Right now it's more so just it happens twice, so just thinking that it happens twice. Alright, here's another example for us. All the problems we were doing before, all the examples we were doing before, we would have two solutions or two roots. Now if you look at this one, think about how many roots we would probably have for this one. That's right, it would be 3, and that happens. We can still use the zero product property. This just has 3 factors. 1 factor, 2 factor, and 3 factors. So all we have to do is we'll set this up, because if this is equal to 0, I don't care what this is equal to, because if I multiply by 0, the whole solution will be equal to 0, and that's what we're trying to find out. Okay, so when we go to solve this, you should see that we have a root of x equals -1, or x equals 3, or x equals 2. So those are your 3 possible solutions. That's going to make this equation equal to 0. That's the goal of this whole section. What will make our x value, or what do I substitute into the x to make the whole solution equal to 0? And for this particular one, it would be -1, or 3, or 2. So that one has 3 roots, and they're not repeated. Alright, so now in the next example, what I'm going to show you guys is all the problems we did previously were in factored form for us. But then you might be thinking, well, what if it is in standard form and I want to use the zero product property? And think of the zero product property. That means that you're multiplying some things together, right? So if it's in standard form, I'm not really multiplying. So what we have to do is we'll have to factor to put it into factored form. So let's take a look at this example. Alright, so we have 4x to the 4th plus 24x cubed. So you have to think to yourself, first, is it in factored form? So I'm going to look at this and go, no, it's not in factored form. So now we have to do the capability, or we have the capability to put this into factored form. And what we're going to use is we're going to use basically the distribution property, but we're going to use it backwards, right? So we want to think about what these numbers have in common. So if you think about 4 and 24, what could I factor out of 4 and 24 that they both have in common? And I would go, okay, I know I could take a 4 out of each one, right? And then what I want to do is I want to look at these guys and go, okay, what do both of those have in common? And I go, okay, x to the 4th here, that means it's x times x times x. So, and this is x to the 3rd, so it's x times x times x. So that means I can really take out x to the 3rd. What would be left over though? So we have to think what would be left over, and I know that if what I take out of this would be just a x value, right? And what would be left over here would just be a 6. So think about what we're doing. We're really factoring out or using reverse distribution, but it's really called factoring. Some of you guys already know this technique, but now it's in factored form. Okay, so this example is really just to show you how to factor when it's in this form. So when it's in standard form, how do you get to here? And then eventually I'm going to show you different techniques when it's not a binomial. What do you do when you have a trinomial? How do you factor when it's a trinomial? And I'll get into that a little bit later. So from here you could solve this, but for now all they're asking us to do is to find the greatest common monomial factor. That's really just using reverse distribution. So that's how you do it. You want to look at both of these, see what they have in common, and really we're dividing out or using reverse distribution, because if you think about it, if I put this back in, right, if I said let's go back into it, you would get the same thing that you had up here. However, we don't want that, so I probably shouldn't have put that there, but what we really want is we want the factored form, which that's why we did out all the work, and that's the goal. So that's how you do it. That's how you put it into factored form, and you guys, good luck with it. Alright, so here is an example of how we would have to factor to solve, right? The previous example, we were just trying to find that greatest common monomial factor. This one, that's what we'll have to do, but then we'll also have to take a step further and then solve it. So we want to look at this and go, okay, I know that this is standard form, so if it's in standard form, all I have to do is use, since it's a binomial, I'm going to look at it and go, okay, I can factor some things out. So I know a 2 and an 8, I can divide both those by 2. So I'm going to take out a 2. X squared and x, I know I can divide both of those by x, so I'm going to take out an x. And then what would be left over would just be an x here and then a 4 here, equal to 0. So now you should see It's a product of binomials, so that means I can use my favorite thing, ZPP, zero product property, and I can state that this is equal to 0, and then this is also equal to 0. So my two answers would be x equals 0 or x equals -4. So I'm just solving this, dividing by 2, subtracting by 4, using your inverse operation. So that would be your solution, or again, your roots, right? Those are the roots. Okay, so that's one way of doing that one. All right, here's another example for you guys. Now, make sure you write this down because this one's a little bit different than what we've done before. The ones that we had before were in standard form. So what we need to do is first put this into standard form. So that would be that's like our first step. So to put this in standard form, you guys should be yelling at the screen, subtract that 15n to both sides, and that's exactly what I'm going to do. So if I subtract that to both sides, I now have it in standard form. That's the very first step. Sometimes it will be in standard form for you, sometimes it won't, so make sure that you do that. All right, so now we're going to go ahead and factor it. We're going to use reverse distribution. I'm going to look at the 6 and the 15. Those are both divisible by, the highest number that they're divisible by is 3, so I know I can factor out a 3. And then I'm going to look at the n squared and n, the highest variable there that I can factor out or distribute, reverse distribution I should say, is n. So this would be, once I take 3n away from this is 2n minus 5. So that right there is now in factored form. That's what we have to get it into to use. Again, my favorite thing is ZPP. Once it's in that form, we're good to go. So you can solve this as I'm solving it. So your solutions to this particular problem would be n equals 0 or n is equal to 5/2. And again, remember the steps that we did. We had to first put it into standard form. Once it was in standard form, then we factored it using reverse distribution, and then from there we used ZPP. So those are your steps, so it might make sense to list those steps out. If you need to rewind it a couple times, list those steps, because those steps will pretty much be consistent throughout this section. So good luck with this. I have faith in you guys. You can get this. Remember, if you have, or make sure that you post a question and make sure you summarize your notes, and then we'll do some practice next time I see you. Good luck. Say hi to the kids out there.
Hi.
Say hi, Andover.